Today we are going to understand the system call. Okay, and we'll see the fork and exec system call. So let's start the class for today. So what is a system call? So the system call provides an interface to the services made available by an operating system. Now, what happened here is we have generally two mode of operation, as we all know. So we have user mode and we have the kernel mode. User mode is for the application program that is run by the user, and the kernel mode is the operating system related programs. Okay, so if a user is running its program and program need some resources, so the resources, as we know that what are the resources that a program is required is the hardware resources like CPU, right, RAM, or we have let's say the printer, scanner, okay, NIC card, right? Let's say the console or the display. We have the input like keyboard. So we have different type of requirement by a user. So a user is running its program in the user mode, and if it required any of the resources, it may be files, it may be different devices, right? So if it required any of the resources, so they have to run into the kernel mode. And from the user mode, how we are going to get all those resources, we are going to get all those resources using the system call. So the system call is actually a sort of functions, sort of routines, which are used to locate the resources to the system, to the user program, and it will convert into the kernel mode, or it will make available all the resources which are there by the operating system to the user program. So for that we use system call, right? And in the kernel mode, we know that we doesn't require any type of system call. Kernel mode itself can use all the resources related to the system. So it is called privileged mode, right? It is called privileged mode. So in the privileged mode, we actually doesn't require any type of system call. Now the thing is that when in the kernel mode, if all the resources are already there, so why the user mode has been created? Okay, why not all the mode will be the kernel mode? So we doesn't require a separate system call for that. The reason behind these two separate mode is very simple. What happen is when there is any bug into the application program, so it will be rectified by reinstalling it or by using the patch of that particular system. But if the bug will or the hang or the trap could be resolved, but if any bug occur into the kernel mode, so the whole system will be crash and your whole operating system will be dysfunction. So that's why, to have a security point of view, we have two separate mode, user mode and the kernel mode. So the kernel mode, we do not touch the kernel mode it is executed by the operating system itself, and we just give a request through the system call that I want all those uh, resources which is required by my program. So for that, I use the kernel mode. So the system call will help you to get all those resources which are provided by the operating system and which will be used in your program or in your application. So for that, we have the system call. So the system call is a programmatic way in which computer program requests a service from the kernel of the operating system, right? So system program is nothing but we do make a request through the system call that we required all those services which is useful in that particular application. So for that, we'll use the system call. These calls are generally available as routine written in C and C++. So as most of the operating system are developed in C and C++, so all those systems call are also there in C language. So this is a general way of defining the system call and to use these system calls. Now let's talk about the two system call, which is called fork and exec system call. So the exec system call is the system call is invoke the process of process is specified in the parameter to the exec will replace the entire process including all threads. So what happened is this particular system call. So whenever we are running any program, that program we have to or the file, the executable file, we have to put inside the exec system call .exe or dot any type of executable code. We have to write out, let's say that 123 or .exe. So that is the program through exec system call we are requesting to the operating system. So what exec will do is exec will execute that particular process, that particular executable program, and what it will do it will replace the entire process. Whatever is running, it will just replace it with this. Okay. So in the previous lectures available, I told you to go through that. In that, it is very clearly mentioned that how the exec system call will be work in monolithic kernel and how it will be work uh, in a macro kernel, right? So in these two type of kernel, how the exec will be useful. So uh, in the kernel where we have the microkernel and we have the monolithic kernel. So we in the monolithic kernel, the whole uh, process will be used into the kernel mode. So and there is very less user mode are available. But in the microkernel where the user modes are separate, the different functionality is also being separated. So in that we need this particular system call, which is called fork. I told you in the reason why we required fork system call, why only exec system call is not sufficient. Now, what is a fork system call? So fork system call is used to create a separate duplicate process. And it is required. Why it is required that exec will replace the entire process. Means whatever process is running and whatever process is invoking the exec, it is just replacing it. So what we required is we required a process, let's say P1, if it is executing anything and it is requiring a process P2. So previously what will happen is when P1 required P2 to execute, so P1 will be replaced with P2. All right. But what we want is we want P1 as well as P2 to be coexistent. So for that, we require another type of system call, which is called fork. Fork, what it will do is if P1 is required to execute P2. So it will use the execution exec system call. But the thing is that P1 and P2 both will exist simultaneously. So that is the beauty behind this particular fork system call. So for what fork system call will do is it will create a separate or duplicate process for that. So that P1 which has been deleted will not be deleted. So let's see in detail the fork system call, and we'll see different programs related to it and try to understand it. So the fork system call is used to create a new process, which is called child process. So whenever in a program, let's say we have a program and in that we are using the fork system call. So what will happen is, let's say this program is P1. So this program is running, and whenever we got fork, it will create another program or another process, which is called P2. So here in this case, P1 is the parent process and P2 will become the child process, right? So what it is saying that this system call is used to create a new process, which is called the child process. So the new process, which is created by this P1 is the P2, which is the child process, which run concurrently with the process that make the fork system call. And this P2 and P1 both are running concurrently, right? Concurrently with the process that make the fork system. So who executed the or who created the fork system call? Fork system call is created by the parent process. So the parent process P1 has executed the fork system call. Due to that, another process will be created, which is called child process. After a new process is created, both process will execute the next instruction followed by the fork system call. Now, both one, because P1 has executed the fork system call, so P2 is not going to execute the fork system call. It will execute the instruction which is after the fork system call. It is clearly mentioned here that after the new process is created, both processes will execute the next instruction following the fork system call, right? So it doesn't mean that if P1 is having the fork system call, it doesn't mean that P2 will also execute the fork system call. The fork system call will execute once by the parent process, and P2 will not going to execute the fork, but it will execute the process which is after the fork. Okay. So the child process uses the same program counter, same CPU register, same open file, which is used by the parent. So the parent is having the attribute, right? Different attributes are there. So in that we have the program counter, we have the CPU register, we have the list of open file. So all those things will be same for the child process. It take no parameter and return an integer value. So what it will do is it will take no parameter. Who the fork system call will not take any parameter and it will return an integer value. And so below are the different return value. What are the different integer value it is returning? So either it will return the negative integer value, right? So when it will return, the fork will return the negative integer value. So the creation of the child process was unsuccessful. So once this, whenever the process, it is a child process, is unable to create by the fork system call, so fork system call will return negative value. Now fork system call will return 0 to the newly created child process. So the child process will get the value by the fork system call as 0. Okay. The positive value, any positive integer, will be returned by the return to the parent or the caller function. Okay, so the generally the function, let's say the P1 function is the caller function or the parent function. So it will, the parent P1 will get the positive integer from this fork. P2 will get 0 from this particular fork. P1 will get negative integer from this fork if P2 will not able to create. The value contain process ID of newly created child process. And this value, this positive value is nothing but the process ID of the newly created child. Process ID of the newly created child. So once the process will be created, so as we have discussed that what are the different attribute of the process. So one of the attribute is the process ID. So the process ID is available and it is there with each and every process, which are right now executed into the system. So I hope you understood it. Most of the functionality what I have discussed just now, that you can find it in my previous suggested video. Now let's talk about this fork system call and try to understand with different programs, different type of programs. Okay. Let's see this particular program. This is a simple C program. And in this program, what will happen is you assume that this is a program, this is one program and one process, right? So in one process, we have a call system call, fork system call. So whenever we got this particular fork system call, what will happen is another process will be created, right? So here what will happen is, let's assume that this is P1. Let's assume that this is P1. So what will happen is whenever we got the fork system call, another P2 will be created. Let's say this is P1, so P2 will be created. Now, what it says that whenever we create the, or whenever we call the fork system call. So what will happen is parent will be created, child will be created. So assume that that program is P1. And whenever we execute this particular fork system call, so what will happen is P2 is created. What is created? P2 is created. Now, this fork is executed by P1 and P2 is created. So once the P2 is created, what will happen is fork will return the value. Fork will return some positive integer. Let's say it is returning 100 and it will return 100 to P1. Okay. And it will return 0 to P2, which will return fork system call will return. Both process P1 and process P2 has separate process ID. There is a process ID for P1. Let's say the process ID is 99. And for P2, the process ID is nothing but what it is returning. So it is returning 100, right? So this is the process. So it is clearly mentioned here. The parent will be returned the positive value by the fork. And this value is nothing but the process ID of newly created child. So it is getting 100 and P2 is getting 0. 0 is not the process ID of the parent, okay? But 100 is the process ID of the child. It is just the return value of the fork. So fork is returning the value to P1. Fork is returning value to P2. Now, after executing this fork, what will happen? What will happen next? Next will be the we got two processes, P1 and P2, same process, duplicate process, but P1 will not execute the fork again because P1 has executed. P2 will also not execute this fork. Instead, it will execute after the fork, whatever the instruction is. So the instruction is hello world. So now hello world will be printed by either by the child process or by the parent process. Okay. So it will be printed. So definitely if we have created two process, definitely that hello world is going to be executed two times. One from the child process, another is from the parent process. Okay. So it should be created, and see here, 2 time hello world will be printed, right? 2 time hello world will be printed. So sometime what will happen is the output will vary depend upon the system, right? So sometime we are the simultaneously it is not executing, sometime it is executing after some time, right? So it doesn't matter. But what we are thinking is both parent P1 and P2 are available into the main memory, and whenever they will get the CPU, they will execute. So as you can see, the output is hello world 2 times. Okay. Now let's see another program and try to understand. So I hope you are able to see this program, right? Now the second program is also very simple. In the first program, we have only one fork. Here we have two more fork, means total number of forks are 3. Now you assume that this is P1, okay? This is P1. So I am writing here. So I have P1, okay. Now first fork will be executing. Now if first fork will be executed, so I will getting a child process which is P2, right? Now, so we have two process, same line of code, two process, but P1 and P2 will not going to allow to execute this fork, because this fork is over for P1 and P2. Now come to the next. This fork will be executed. Now the second fork will be executed. So what will happen is one child process will be created here. One child process will be created here. So let's assume that it's creating a child process P3. It is creating a child process P4. Okay. So now every process has the same program. Okay. Now the next process is going to execute the next fork. So next fork will be executed again by every process. So next P1 will be executing that fork. So another process will be created, let's say P5. P4 is executing it, so another process will be created, let's say P6. P3 is also executing, so another process will be created, let's say P. Okay. Let's start with the beginning again. So there is process P1. Process P1 is created. P2. Okay. Now P2 is there. P2 is going to execute this particular fork. So as well as P1 will also execute this particular fork. So we have, let's say, P3, and let's say we have P4. Okay. Now all these are executing the third one. So here one will be created, let's say P5. Here one will be created, let's say, sorry, P1, P2, P3, P4, P5, P6. This again will be creating, and this again will be creating. Okay, so after executing all these three fork, we have how many process? P1, P2, P3, P4, P5, P6, P7, P8. If you have doubt, I'll repeat it once again. I'll repeat it once again with different colors, so you will not have any issue. So assume that this is your P1. So this is your P1. So P1 is creating the first fork. So which is created? P2 is created. Okay, let's say P2 is created. First fork. Okay. Now P1, P2 both are there. Both have same line of code, but they cannot execute first fork. Now both will execute the second fork. So once the second fork will be executed, so P1, P2. So let's say P1 is executing first, so it will generate P3. P2 will execute after that, so it will generate P4. Understood? Now, after that, because all the processes are same, but they cannot execute this particular fork, they will execute afterwards. So they will execute this fork. Now, after that, once they will execute this particular fork, so how many processes are there? Four processes. They will create their duplicate. So P1 is creating its duplicate. P3 is creating its duplicate. P2 is also creating its duplicate. And P4 is also creating. Okay. P1, P2, P3, P4, P5, P6. Okay, 4, 4, 2 times I've written, I think. It's by mistake. So it is creating, let's say, 7 and is creating 8, right? So in that way has been created. So fork, the first fork the first fork is able to create P2. The second fork will able to create P3 and we are in another function. Here we have the main function. Inside that we have a function. In it is having the definition in which we have a if statement. If fork is equal to 0, is equal to 0, then hello from child, else hello from parent. So why it is written is, when we call the fork system call, as we know that a child process will be created, and fork will give 0 to the child process and process ID to the parent process. So if the child will be created, definitely this hello from child will be coming as output. And if it is a parent process which is running, this hello from parent will come into the output. So we may have hello from parent, or we may have hello from child and hello from parent, both will be printed, because the the process will be created by the fork, the duplicate process, but they are not going to execute fork again. They are going to execute the instruction after the fork. Okay, so once we'll run it, let's see what are the output. So it is saying hello from parent. Let's run it again. Yes, so it is coming hello from parent as well as from the child. So what will happen here is, here the parent process is executing first. So because the fork is already been called by this particular process, but it is not equal to 0 for the parent, right? Fork is not returning 0 for the parent. It is returning other value other than 0, means some positive value. That's why this is coming as output. And for the child process, the fork is giving 0, so the child process will executing this one. So the both statement, this statement or this statement is printing as output. So generally you will not find it if the U doesn't have the fork system call. Either this statement will execute or this statement will execute in a if else. Both statement will not going to execute. But here it is executing because it is creating two processes. That's why. So this is the live example you can see. With that, you can understand the parent as well as child, both are created. Let's say this particular program. In this, we have a global variable. We have the same fork system call will be there, but it is equal to 0. So the child process is going to execute and it is making plus plus x. Else parent process will execute, it is doing minus minus x. And we are calling it with the function. So this function will be executing, x will be equal to 1 for both for the parent process. And as we know that both are sharing the open register, the CPU registers, the program counter. So definitely both will share the same variable, global variable. So let's assume that this is P1. This is P1. And the value of x to the P1 is 1. Okay. Now, after that, what will happen is, because this fork system call will be coming first, so it is executing and P2 will be created where the same value will be x. Value will be 1. Now, both P1 and P2 will have the same instruction, but both will not execute this. After that, it will execute. So after that is what? Equal to 1. Is equal to 1. So the child, what it will do is, child will do plus plus 1. So whenever the child will execute, it will print as output as 2, the x value as 2 plus plus 1. And whenever the parent will execute, it will do minus minus x, means it will print 0. So what will happen is, what is the output? The output will be either 0 or 2, or the output will be either 2 or 0. It means that either the parent function will execute first and then child process. Here, the child process is executing first and then parent process. Because both are executing simultaneously, so we don't know which process will execute first, right? Let's run it. Okay, so it is, we want that both will execute, right? Both will give the value. Yes. So here you can see parent is also giving the value and child is also giving the value. So here parent is executing first and then child is executing second, right? So this is another example of fork system call. That how it is working. Let's see one example in the Python. Now in the Python, what we are going to see is we are going to see the same concept. Here for the Python, using the fork system call, we have to import a library called OS library. So we have to import OS. Then we defining a function called child, parent child. In this, os.fork will be executed and the value will be returned because fork is returning two value, either 0 or some integer value, right? So if n is some value, so the parent process is going to execute and its id is going to print. If the n value is not greater than 0, means it is equal to 0, then child process will executing this and it is printing its process id. Okay, and we are calling the this particular function. So once we calling it, it will execute. It will be given the value, the fork. The fork system call will be called and it will give the value. This value, the parent will be given the value as some positive integer. The child will be given the n as some 0, right? So let's execute it. So once we'll execute it, the parent process and its ID will be there, and there is a child process and its ID will be there because both will be created. The child process is also created and the parent process is also created. But I want the ID, right? So the parent process is getting the ID this, and the child process is getting the ID this. Okay. Okay. Let us try to print the value of n also. Let's see. Yes. So that value of n is nothing but the fork has given to the parent process. So as I told you, the parent process will be given the process ID of the child process. So here you can see the child process ID is this. This same child process ID will be given to the parent process by the fork system call. Okay, so the fork system call has given the value n, and this n value I am printing here. So it is printing the value, and this value is the same as the child process. Okay, when I'll execute it again, definitely child process will be another child will be created and the process will be different. So the parent process is same, but the child process is different again and again. I'm executing it again and again. Again, I'm executing is giving the value again. So I think you understood the functionality of the fork system call and exec system call. Exec is just for the execution. It will replace whatever process is called the exec system call by the process which is there in the exec system. For the monolithic kernel, it is okay, but for the microkernel, we need the fork system call. So that's why we are learning the concept of fork system call. This is one of the gate question that is that came in 2015 or 16. It says that the process execute the following code for I equal to 0, I is less than n, I plus plus, and the fork. The total number of child process is created. So how many number of child processes created? The fork is going to run n times. So we know that the total number of process that is going to be created is 2 to the power of n, and n tells us the number of fork system call. Here also n tells us the number of fork system call. So this is for the number of process that is there in the system, but it is saying that number of child process. So the number of child process will be 2 to the power of n minus 1 because 1 is the parent process. The answer will be B. to the power of n minus 1. Okay. So if we have fork system call three times, so how many child process will be created? It will be 2 to the power of 3 minus 1, which is 8 minus 1, which is 7. 7 are the number of child process. Okay. What are the total number of processes are available with these? It will be 2 to the power of n, which is 8.